I wanted to provide a little bit of help on questions 11 and 12 from the homework, being as they can be a little bit challenging. What we have is a rotating body that, as this object spins, we'll have some tension being applied to the swing, and it will cause our rider to raise out. And so what we know from the information given in the question is the diameter of the actual turning mechanism. We know the length of our chain attached to the swing. We know the mass of the swing, and we know the angle that the swing is sitting at. Being that we do have a device that is spinning, we recognize that we have to have some centripetal forces that are occurring. And so we need to draw a free body diagram to try to identify what forces are acting on our object and what our focused object is. So the object that is being spun around is our rider. So our rider must be feeling a centripetal force directed inward. So we need to identify what force that is, being as it's always a component of one of our other objects. So in order to figure out what forces we have acting on our mass, I'm going to draw a free body diagram. So I have my rider, and that rider has a tension being applied upward at an angle. It has its weight from gravity being applied downward to it. We don't appear to have any friction. We don't really have a surface to worry about, being as the seat is not touching the ground or anything else. So these are the only two forces that we really have. We know that the tension is being applied at an angle. So what we're going to need to do is probably break that tension up into components and recognize that part of that tension is being applied vertically to balance out the weight, and the other part of that tension is being applied horizontally, and that's what's going to act as our centripetal force. So our centripetal force will be equal to the tension in the x direction. So the question becomes, how will we figure out the value of these forces? So in the x direction, our net force is going to be the x tension. That will be equal to our centripetal force, which we know is equal to mv squared over r. In the y direction, our y tension is equal to the mass of the chair times gravity. Being as we know the mass of the chair and gravity, we can easily figure out what this value actually is. So then we can figure out the value of the x component using a little bit of trig. If I think about my standard triangle, the actual tension would represent my hypotenuse. The x value of my tension and the y value of my tension will be my legs. We knew the angle that was provided from the top corner. So that means that I can recognize my x tension as my opposite side and my y tension as my adjacent side. So we know what the value of the y tension is, and we know the angle. Therefore, thinking about my trig functions, let's see, adjacent, so I can't use the sign, and what do I want? What's most important to me? And what's most important to me is going to be the extension of the opposite. So I'm going to use the tangent function as my math. That means that the tangent of the angle that's been provided is equal to the opposite, which is my extension, over my adjacent side, which would be my y tension. So I can determine my extension by reworking my formula. And once I know this value, I should be able to take it and set it equal to our centripetal force. We'll actually see that the mass isn't really necessary. They did give it to us, but I can cut it if I want to, so that's a personal preference. I think the challenge here becomes, how do I determine my radius? So let's take a look at our image and see if we can't figure that out. So when we think about the equation for the radius of the rider, what we're really looking at is how far from our rider to the center of the ride itself. So how do we figure that out? Well, we know the diameter of the ride. So if we cut that in half, it'll give us the radius of the ride itself. And then we would need to add to that the length of from the ride to the rider. So we would need to add this x component of the length. How do we get that x component of the length? Well, again, we were given the length of the chain, and we were given the angle. So in the same way that we use trig to break apart our tangent function, or our tensions, we should be able to break apart our length. So you have a length which can act as my hypotenuse. My x value would be the opposite side of that. So with a little bit of trig, I can replace this with a sine function. And I can get my radius that I would need in order to be able to plug in and solve for my centripetal force equation. So all together, this becomes the radius that we actually care about. Hopefully these notes help. Should pretty much lead you into the setup for question 11. Question 12 becomes a pretty easy question when you kind of go back and think about these different characteristics that I've just discussed. Good luck.